Okay, so we are going over denial of service attack today. Pretty fun. Concept is, sometimes could be complex, but it will start out with defining what it is, how some of these attacks are impacting different type of servers. And I did pull some stuff that's pretty recent, that is researched by Microsoft to share with you, because those things you need to know need to be more current, because a lot of the denial of service concept has been around for a long time. So we'll talk about different types of attack and the difference between distributed denial of service compared to regular denial of service. So with this, we'll be able to do Unit 7 assignment. So DOS is known as denial of service attack. This is when you have a single target and you're attacking from a single system. That is one-to-one. Now, most of the times, well, all the times that you see denial of service attack is really capitalized on making things unavailable. The resources that is being attacked is going to be taken down or being disrupted, so that way it's not being available. Hi, you're going to need a drive today. The common target that you see would be web servers, because web servers are publicly available. So let's imagine that if we have an e-commerce website, our users are logging in or looking at different items. Hi, we need a drive today. To purchase. So something kind of like Amazon. So a denial of service attack is really the attacker would target that particular e-commerce web server, and its related entity to take it down, so that way no customer could access it. So in the first question of our assignment, and I thought I had it up, sorry. It asks you to describe the purpose or the primary purpose of denial of service attack. And we know that in cybersecurity, we have confidentiality, integrity, and availability. And denial of service really is an area that we looked at for availability, right? So this attack focuses on making things unavailable for that organization. So the purpose of it is to exhaust the target's resource, whether it is web service or data, downloads, etc. Sometimes it could be bandwidth on the network. So basically they would floor your bandwidth, making your network very, very busy. And so that way none of your systems can be connected or have any kind of throughput. Yes.
So somebody can be like on Wireshark and like download the video and send it to somebody else.
No, Wireshark can be used just to monitor what the available resources are, and that's where we normally start, is to look at a sniffer, and we'll see some of that today, to see what type of ports are open, and then use that port to attack. So most of the form of attack that you see would target specific ports, right? Think of it like the open doors or window to the mansion. We will go through that mansion and create havoc, right? So that's the attacker standpoint, is to get into an area that they can use, the service or the ports they can use. So if I'm the attacker, I would scan and see if you have HTTP service through port 80. Or if you are using HTTPS, right? That might be a little harder, but I would say, okay, I just sent a bunch of requests to your server. So your servers become very busy and it's no longer responding. Now, in the bandwidth area, they can just generate a lot of packets or send packets, and then it becomes occupied, right? Your systems will have to handle forward or send packets from one to the next. And sometimes that they would spoof the IP of the system on your network to do this. Most of the time they do. And then with the server, they want to capitalize on the unavailability of that server, so processing power, because it would constantly need to process requests or execute some kind of process. And sometimes they would capitalize on making the memory unavailable for applications. So ultimately, making the system become unavailable to the users. So that's denial of service. So some of the techniques, and you can find this on our notes, the techniques that would be used to perform for denial of service tends to be flooding. So I can flood a system by continuously sending a specific set of requests. So I know that the web server, right? HTTP is under TCP suite, and TCP, Transmission Control Protocol, require SYN-ACK, right? In order to communicate the server with the client has to establish the synchronization and acknowledgement with the server. So that means that the server has to acknowledge that the client wants to communicate. So you can do a SYN flood, or you can do a SYN-ACK or TCP. It's also known as TCP attack. So the flooding the target is a very common technique. It's not the only technique, but it's probably the most used. Okay. So for question number 2, we can say using flooding. And sometimes that could also be network traffic. So a lot of the times when we flood, we generate network traffic. The web server is connected to the network, so it is the same. And you also see the other area, and this is application-based attack, is to exploit the application vulnerability. So if you're looking at network-based, it tends to be flooding. If you're looking at application-based attack, it tends to be exploitation. Yes.
Is there different types of network trafficking that or application traffic like?
Yes. So for HTTP, as we saw on Wireshark before, right? HTTP, you would see that type of traffic coming through, and it uses port 80. Right? And the packets for HTTP, it would have HTTP header. So because the header is like the mail label, it would be used to tell the system where it's coming from and where it's being received. All headers tend to have source and destination, but for HTTP, that destination possibly is the server. So once the server sends the page, or it serves the web page to the system, that is also contained in the packet itself. So think of it like, you know, if you put when we use Wireshark, it's like a camera system, and we would see all different cars going by. You would see a truck, you would see a sedan, you would see different types of car. And packets are that way. Some packets, would have, like, certain cars would be a certain model and it would be very common, or or a certain car would have certain capacity, like an 18-wheeler would have more content inside. So you would have packets in different sizes, and your data is broken up into different packets. So yeah.
So eventually when they go to attack, all those, like you said, like the truck, like everything that's in it, it just goes out.
Yeah, sometimes they can also generate traffic. So a lot of times with the flooding, what we're doing is we're really sending additional traffic. So instead of just one system communicating with another system, I'm sending many packets from my system, right? In a regular HTTP traffic, you might have only so many packets. But you're going to see today when you do the lab, when you are generating packets or you generating traffic of flood, you can send 500 different type of requests. And with that, it would generate more traffic. So you adding more cars into that, and it creates congestion, and eventually there's no throughput, right? You have traffic and nobody goes anywhere. Okay.
Is that all you do though? You letting somebody, you're not getting no.
Yeah, you can exploit vulnerability. but it's ultimately it's just making things unavailable. Yeah, when you flood, tends to be that it slows it down. And then it becomes, so the system here, I mentioned buffer overflow because buffer overflow is a form of denial of service. You would see that when the system handle certain sessions or session requests, it stores that information into the buffer. And when you have excessive storage, it becomes, there's no more room on the buffer. So buffer is what? You guys know what a buffer is in server system? It's just a location of storage where it handles a lot of the temporary storage. So how does a computer know what is being requested, right? So it stores it in, think of it like a list of queues, right? Like you getting in line. So if I have a really long line, it's going to take the system a long time to handle. Or if you have, like, we would have one parent, and in normal traffic, you might have 4 or 5 kids asking the question at the same time. Yeah, the system is going to be able to handle that. But if you have one parent and you have 500 kids asking many different questions at the same time, that's going to congest the parent, and the parent's going to get overwhelmed and not be able to answer. And that's, think of the server that way. So in order to handle all the requests, it stores things into the buffer. And when the buffer becomes overwhelmed or overused, right, it won't be able to identify what needs to be handled. So that's one way, right? And then the purpose information is here. There are 2 types of DOS attack, and I kind of wanted to break it down. The more common one that you see is going to be network-based attack. And then the other one is the application-based attack. Basically, you have to scan for vulnerability. We talked about this before. We've done a lab when we scan for vulnerability. But it capitalized on software application and software vulnerability. So what's their motivation? A lot of it is just, they get paid to do it. Okay. They sometimes get upset at a certain company, and that will be a revenge. Sometimes if they're paid, it could be a competing company or a nation. That also could be the case. And then some of it you would see that would fall into hacktivism, right? So for example, Anonymous doesn't like someone. They want to make a good political stand on certain political website. They would hack it, right? And just making it unavailable for 48 hours. Imagine if Amazon goes down for 48 hours, how much money that would be, right? So financial loss is a huge area with denial of service attack. We quantify that in the 30-minute span, and I was reading the research article that they did for Azure. When they look at a lot of these attacks, it only happened in the 30 minutes, 20 minutes increments, right? But it takes down like so many different cloud instances that it becomes millions of dollars lost for a lot of companies. So you see that, this is a dangerous area. And here I included how you can combat some of these things, and we'll go through them. Okay. So let's take a look at your assignment. So let's kind of identify based on the scenario, because certification, a lot of times they give you scenario. So question 3A. An attacker disrupts a function of a popular e-commerce website by sending flood of SYN requests to the website server. So whenever that I'm communicating with a website, like you typing in the URL, google.com, in the back, we know that it is a SYN packet that is being sent to google.com, the domain, right? Because TCP needs to have that synchronization to establish the communication between one system and the other in a client server environment. So SYN requests. So if we generate a lot of different SYN requests, like 1,000 at once, that can cause the server not be able to synchronize. It's overwhelmed, just like 500 kids asking the same question many times, right? You're gonna get overwhelmed. So the connection becomes deteriorated, and also the system becomes deteriorated. This is known as a SYN flood attack. So the key word here is the SYN request, and that will be SYN flood. Okay. For 3B, if they forge a reset packets, so this they're crafting the packets. So, and then they're gonna generate that packet and they send it to a bank server. This allows them to impersonate a user or a system for transactional purposes. Okay. So what that means is the attacker sends a fake packet to the system, and they also need to spoof and also terminate the legitimate user communication, right? So basically it is an impersonation attack with a flood. So they would flood the user system so it can't communicate anymore. And then they would pretend to be the user by forging the packets, and they would do some ARP spoof with that, right? And this is called a reset attack or a TCP reset attack. So some are more complex than others. And then for C, the attacker floods a company server with UDP packets. So we know that there's TCP and there's UDP. UDP is often used for things that doesn't need reliability, right? Communication that doesn't need reliability, like online radio. So UDP packets can also be generated to exhaust the server or the system. And so UDP flood attack. You guys know which server uses mostly the UDP?
Windows.
No, a server role. I should be clear. So we know that web server uses TCP. We established that, right? HTTP is under TCP. Some web server can also use UDP, but there's one specific type of server that mostly, and I know you've seen this because I wrote it in the Wireshark lab.
Yahoo.
And I've done, so which server? Is it a DHCP server?
Yahoo.
Is it, what kind of server? So DNS traffic mostly is UDP, port 53. So you know that web server is tied with DNS, right? It has to have a domain name system to translate URL to IP address. So attacking the web server is, its job is to give you the web pages that you need, the content of the page, but it's tied to a DNS, which is a domain, right? When they register for a domain, they have to have a DNS. It's either cloud hosted by someone or they have to have their own, the .com, the .net, all of those things. So yeah, that's, you often see like the DNS form of attack is in the UDP type of traffic. Okay, then we have a ping flood attack. Okay, so this is also known as ping of death. Yeah, in the 80s, in the 90s, that's what we used to call it. So it generates a lot of ICMP echo type of packets. And so whenever you see this, it's often used for ping or trace route or anything that you want to follow the traffic. So when you ping a system, you type in ping in the IP address. So imagine that you ping 50,000 times at once, right? It's gonna, because when you ping, it sends a request, the system reply. So in Windows, when we ping, there are only 4 packets each time. In Linux, you can do a count or it continuously ping. But if you just floor it with 50,000, a million packet at once, guess what happened? It overwhelms and it doesn't respond. That's why it's called ping of death. There's also another attack that's using this technique. It's called the Smurf attack. But the Smurf attack also needs to have an ARP spoof technique that's incorporated. So it does do an ICMP echo request, but you also have to do an ARP spoof. That's why it's called the Smurf attack. Yeah. So today we're gonna use a tool called Slow Loris. but this is also a form of exploitation. This this is a way that the attacker would exploit the vulnerability to limit concurrent connection. You know that web server needs to have many concurrent connection. I want to serve millions of people in the world, right? So this is a way that it would generate an attack to limit the concurrent connections and keep the target connected to it, and then generate a lot of different type of requests. So how do we really kind of slow down the attack? In security, we know that we cannot prevent things 100%, right? We would reduce the risk or mitigate some of it. So you would start out with monitoring your network traffic always, because your system will tell you exactly what's going on and its health. And in that, we would need to inspect network traffic. Security appliances are really good at inspecting network traffic. When you monitor, think of it like a camera looking at the road and looking at all the cars go by. When you have the inspection feature that's incorporated, you zooming in on specific cars. And we can set up the rules for security appliance to really identify which car to really look at carefully. For example, things with high payload or from a certain IP address, because potentially those unknown or risky IP addresses can possibly be a source of attack, right? So once we find those, we would redirect them. So you would set up a route for all the anomalies, the abnormal traffic. So just think of it this way, right? If you ever cross the border to go visit Mexico or another country, right? You get in line and that's the line of all your traffic packets. Then, but, right, they would have a camera system and they would look for specific, or at the airport, it's the same. Everybody gets into the same general line. And then sometimes they would ask certain people to step out to a specific line where they can ask more questions. They might scan your hand for explosive powder. They might look at, what you have in your bag if you travel internationally. So inspection does that, right? And then we would redirect those people or the irregular traffic to an area where we would check again with additional security appliance. So it slows down the attack traffic, and then we would try to prevent it. So additional system would go through and we can check it against the rule, right? And if it's, if it's normal traffic that just happened to look irregular, it will still get through. It just slow that down a little bit. So you can do IPS, and intrusion prevention system would either deny or allow, right? We would use the access control list to block it or allow it in. Same thing with the firewall. It's looking at ports, it's looking at services, it's looking at where that's coming from, right? And where that's going to as a destination with MAC and IP. And then proxy is just a system that is scan or passing the traffic. So we can also use this as an inspector, like a traffic cop, right? You go here, you go there, no, you don't go, right? So it really depends on the network, but most of the time these things are in place. So how does all these e-commerce websites stay alive, even though there are many? I'm sure if you look at their logs on their firewall, there will be a lot of different servers that are in place. So what happened is they would have, like, if you look at Facebook or Instagram or social media website, they have what's called content delivery networks. And this spread across many different data centers in different regions of the world, right? You might have some in South America, North America, probably many for the people that it serves, but in different region of the world to really absorb some of the traffic and load balance. Because you have millions of users around the world using your website, so it needs to kind of, equally distribute the traffic so it's not congested. But it's also a way that we can reduce attack by distributing the traffic. And with load balance, you have quality of service, QoS. And if you took networking, right, you familiar with that? So how do I set this up? That's through my routing and switching at my data center. So that way your systems will become available. It might slow down if, there's distributed denial of service, but in a way that if you have thousands of servers serving and receiving traffic and absorbing traffic, you're okay. And then ultimately, if we're looking at endpoints like your Internet of Things, your users are using smart devices, we got to make sure that security software or antivirus is used on it. Why? Because this is a way that they can spoof someone else's system by phishing them and getting them to link to, to download something that's malicious, a script, something that they can use to pretend to be that system or to open services for that network through that system. Okay. And then using host-based firewall like Windows Firewall or install an additional software. But most of your security software these days have all of these components: anti-malware, VPN, and host-based firewall. So in order to connect to the network, we got to make sure that these systems meet the requirements, right? Instead of just letting them connect to the wireless network or to the network. Any question?
Would a next generation firewall technically be considered an IPS?
It can act as an
Right.
IPS.
Right?
Yeah. The downside with just using only next generation, because if you only have one next generation, they tend to have many, right? You enable a lot of different features, it can become a single point failure. So they just have to evade the firewall or overcome that firewall, and then it becomes, less secure. So, and they do really well with looking at what those are too. There are ways that you can scan firewall and it will tell you what type of firewall. But vulnerability scanning will tell you a lot about what systems are there. That's the next part, is to evade firewall is our next chapter. Okay, so overall, we would see that, sometime lump under TCP IP attack. So these things were from the first page. But in TCP IP attack, you need to have spoofing, right? So spoofing, just taking on someone else's IP address or identity and using that because, we're not going to allow anyone that doesn't have that address into our network. It's kind of like having an address in the city, right? You have to have the known addresses to that city. You can't just come in and have a foreign address. That won't work. So spoofing is used. You're gonna need a drive today. So I gave you a little bit of diagram here so you can see what a SYNAC attack looked like visually on 2D. Okay. But in this one, you often see that SYNAC is more successful as a distributed denial of service attack, meaning that they would use many systems to target that one victim system, right? So, nowadays you have, with the security measure, the attacker tend to utilize botnets more, and that's how they can get successful. And that's why it's only 20 minutes, because if you are distributed denial of service, you just millions of system attacking at once. If you're looking at the live attack map, when you see a huge flood of things coming across the screen, that's a distributed denial of service attack right there. And you see it often. It's like every other second. Okay. You have ping flood, we talked about that, the Smurf, and then there's only SYN flood instead of SYN act flood, right? But it is in that same umbrella by just using, so it's capitalized on the last part of the acknowledgement on the server side, and then it would use the acknowledgement packet, so it would have more of those to complete the handshake. Yes,
How many tools do you use on average? to use
one tool.
one tool that's significant?
Yeah, if you know, well, if it's just DOS, one tool is fine. But if it's distributed denial of service where you have to take over different system to make them bots, you have to, number one, fish the system, get them to click the link. So once they click that link, you install it as a bot. And with that, you control those. So if I have 40,000 bots and I would turn them on at once, so making sure that they're on, and then using those to launch the same attack. So I would remote into, remote control. So you can have your system is a management console system, and those, you activate the other system. So those are the IP addresses of the system that you're going to use. A lot of time you have to spoof. So like 3-4 tools at once for that. But if you just want to do single system to single system, you can use 1 or 2 tools. Not hard.
Casey,
Yeah.
you have to be around the network, their network.
You have to
do
attach
that?
to the network.
So
yeah.
you can't just do a remote.
You can do it remote. You just have to get in. Remote just means that you're not physically there. All the cloud things are remote. So you just have to, attach to the network. Yes. You have to pretend to be part of that network. Yes. Okay, so here's the reset attack information, UDP flood. So I want to spend this opportunity to introduce some of you and then remind some of you about OSI layer, because this is the crucial model, right, outside of the TCP model to security and networking, right? Like I said, 80% of security is about networking or more than that. So, and I, for as long as I taught, I always come up with a weird saying, so I remember all the layers. People don't need to see purple alligator, physical, data link, network, transport, session, presentation, and application. For Network Plus and anything that's network certification related, you need to know your OSI. So when you plug in your cable that's physical, when your cable is blinking and it's, it's setting up the frame to send 1s and 0, right? At the switch level, it is data link. So when you're connecting your system to a switch, it's data link. When your system is routed, like for example, when you're connecting to a wireless router and you have internet access, that's a network layer being used. But through that, the first layer is established. The first 3 layers is established. And when you're using TCP and UDP services, it starts with the transport. So this is where your packets are being transported. Then when you have a session, when your system established communication as a session, that's here. When you are seeing your page on your browser, that's application and presentation at work. Okay, so the time that you turn your computer on, connect it to the network, open up a website, all of these layers are at work. Okay, why is this important? Because in the attack, you need to know which layer they're operating at to pinpoint and stop the attack. And as a pen tester, you need to know which layer you're operating at when you're attacking. Okay, so when you're doing the flood, right, the get flood, this is when I'm keep requesting the same website over and over again, but 50,000 at once, right? Or more than that, because if they might have a CDN where they have thousands of servers to serve that, I might do distributed where I would have millions, billions of services. Each system would send out 500,000 requests to that website and eventually exhaust it, right? You ever visit a site that's not well hosted and it takes a long time to load? Also, if you ever visit a website really late at night, because I'm up all the time really late, I also see how the site can be really slow sometimes when they're backing up. So when they do a backup, they take the main one down and then they do a slower connection server to set it up so that way, because they already studied, right? They researched and they know that at 2 a.m. in the morning, there's only maybe 40,000 requests compared to 4 million requests. So they would use the server that is slower in connection, and then they would update and they would run, backup on some of the main ones. So with that, if you see on the get flood, it's just basically doing a get request. That's every time that you type in a URL that does a get first. And so it's just keep getting, right? And we talked about, the code for HTTP code 200, 400. So the goal for the attacker in this form of attack is to get the server to say 400, right? Because the normal good server would serve them the page is 200, okay? So on the application, if you're doing a HTTP get flood attack, a lot of the tools, it will give you a report. And you want to get to the 400 level. But on the defender side, you don't want that to happen. Okay. All right. So distributed denial of service attack. I mentioned that this is a way that we can use many different systems to attack at once. And how do they do that? They make the system bots or zombie. So when you hear the term botnets, it's just a bunch of systems that have been taken over by someone else and being used for a certain malicious intention. So how can you tell? Suspicious amount of traffic coming from an IP range or one specific IP. Wireshark tells you this, right? Scanners tells you this. Monitoring system tells you this.
You can sell Wireshark to like look out for that type of stuff and then.
Yeah. So if you look at the destination, you just see a flood of them, right? Like a whole list continuously. 50,000, 100,000, could be more sometimes, right? And coming from the same IP address or the same range, right? So what does a range? When you put in the IP, yeah, the .11, .12, .50, .100 in that range, right? So why is that? Because automated tool is a lot easier if you use sequential. It's enumerating the IP address, right? So that's why it's range. Okay, so let's get to the next part. So I'm gonna bring this down, these two, because I know some of you might still type those. Sorry. And again, you don't have to put it verbatim. You just need to have a general understanding of what this is. It's fine with me. So describe how distributed denial of service attack on a system is carried out. First thing, the attacker tricks the user into installing the malware on the system to establish the botnet. So that will be the first thing, whether it's through phishing technique or a lot of times it's through phishing technique, or just, getting them used to clicking on something, have them visit a website so that way they can download certain things in the back. And then after that, the attacker would send remote instructions. That means that the attacker system becomes the remote controller for all the bots. And usually they have instruction for each bot to send the request. And that can be automated, right? Through the tool things that can be written in Python and say, all of the system in this IP range, right, send this many session requests to the target IP. You'll see something similar in the lab today. The grammatical error on C there. Let me fix it. Becomes overwhelmed with the ED. So you can overwhelm the system with excessive requests, and as a result, it will not be available. It becomes unresponsive or unresponsive.
What would the C2 concept come into play with this? Or would it just be solely the attacker using being the, I guess, commander in this case rather than a C2 concept.
Yeah, for most part, they are the commander, but there are new forms of attacks now. That so instead of making the traffic the same or in that range, what they do now is they're pretty crafty about using different paths and different sources. So,
All to the same vector, right?
yeah, all to the same
But
vector,
different path.
just different paths. Sometimes do a reverse proxy or, setting up different ways that it would bypass a lot of the IPS. Because the rules on the IPS is we were saying, oh, if it's coming from this IP address or if it's coming from this range of IP address, firewall is gonna not detect it. So I think of it this way, the police is saying that everybody's on, that's coming from this entrance of the freeway, we're gonna block, right? We're not gonna let them on. But if you're routing it from different ways, you can still get to the freeway. So, yeah, you can set specific routes, you can set a lot of different things that you can do to identify or to get the system to identify it as a non-anomaly type of traffic. Yeah. So, I'm always interested in how crafty they can get. And so, Microsoft does a good job because they do a lot of like testing on their denial of service stuff for their Azure. So they do a good job with documenting a lot of these things. So yeah, you see a lot of tech company, they publish these things as white papers. So if you're interested, you can read them. And some of the current things, the tools that they use is a lot more advanced. So, and that could be coming from APT also. Any question? Distributed is very, very common, right? So whenever that we say denial of service attack now in the larger span, it's all distributed denial of service. Rarely that you see one-to-one. That's like small time. In the regular industry environment, most of the stuff is done distributed. Okay, so here, there's some additional information. So an example is if we want to really detect the traffic pattern that's really built on historical data or current data. So you basically teach your system or tell your system what would be a regular traffic pattern and what is not. Anything outside of that. So if you have a spike in a specific amount of time, and it doesn't take an hour or 2 hours. When you're using the virtual machine, you're going to say that, yeah, you can leave the attack on and walk away, right? But normally they're going to hit about increments of less than 30 minutes or so, 10 minutes, 20 minutes, 30 minutes, because it's a lot of resources that's being used as a commander for all the other system, right? So it's all about resource capitalization. But if you leave it on for hours and hours, likely that you're going to be detected and get in trouble and be arrested. Second, you're going to use up all your resources. Yeah, you can trace somebody very quickly if you have enough time. So you would see surges like that. And then, sometimes on the web server itself, it also have logs for you to determine. So now NTP, this is not too common, but it is a form of attack and it's often used. So whenever that we have time change, right? Daylight saving, how does your smartphone change? Well, it's because of this. The protocol that we use is network time protocol. So as long as your smartphone is connected to your service provider network or your home network, right? So simply that these are the servers that synchronize time with other servers. And that's how we're able to get the more accurate time throughout, all the network. Why do we care about accurate time? Well, there are times that you need to use it for replication across your domains, synchronizing your databases so that way inventory can be updated across the world. So there are so many things that we rely on because outside of the 60 seconds gap, sometimes system cannot synchronize. So we want to make sure that these are available, and through T-Mobile, Verizon, AT&T, you're able to have the updated time. But guess what? The attacker uses the same thought of concept, right? Oh, okay, well, if everybody's connected and synchronized, let's use the server and floor it. So they do an application of attack, and it would be targeted to a certain address. So they need to spoof the IP address that would be within. Usually that's the case, causing the NTP servers to send large volume in, because the server needs to respond to that particular victim. So basically, it pretends to be the victim, generates the request to the server, hey, serve me, but serve me 5 million times. And the server would be, okay, here it is, boom, right? And so it would overwhelm, and ultimately they also floor the network at the same time. So you would create excessive amount of bandwidth in that case. But if you have bandwidth control, right? So if there's a spike, right, you just need to disconnect that source right away. Okay. So block the IP. That sounds simple, but when we respond, sometimes we have to know, oh, which IP is that, right? Which system is asking? Question. All right, so that would be the next answer. So describe how NTP amplification attack can be performed as a DOS on the network. They spoof the IP address and using the address to make the request to the NTP server. So the NTP server would high rate of response back to that particular system. Any question?
Even with the firewall, you put what the implicit deny, let's say time changes March. So going March forward, do an implicit deny. What,
Yeah.
isn't that typically like the easiest way to play it out?
But
Avoid this.
you have NTP server all the time though. They could attack you outside of March, you know. NTP server is available all the time, right? It's used for data synchronization purposes. You know, replication, you know, a lot of things that we use synchronized stuff for. So for example, like in a domain environment, Active Directory, if I add a group of user, it replicate across the network. So that way, like I don't have to do it again. So you use it for a lot of things, you know, batch processing for databases across your network. So NTP server is always being used outside of just time change. Time change, you know, is one of the smaller things that the system handle, but it makes sure, well, why is that? Because NTP servers need to understand that somewhere in Asia and somewhere in Europe, if we have the wide area network, when we sync the systems there, it uses the universal time also, right? So we, you know, yes, we can set up our servers to be that way, but the role of the NTP server, it's always going to exist for the purpose that all the system needs to agree on that time. So yeah, you can explicit deny during March, but they could attack you in May. So, you know, or January 1st. What?
How connected, like you mentioned.
Yes.
Patch systems and whatnot, so you obviously can't deny the traffic.
So, you know, a better way to look at it is to do a better job at monitoring the NTP server, or controlling the security for how the NTP server respond or the request. So you can control your appliances by saying, if it exceeds 50 packets, just drop it, right? Or redirect the traffic elsewhere and not send it to the NTP server. And then you don't really have the ultimate issues at the end, right? So a lot of the things that happens, it's because we overlook or simply just, you know, not care enough to fix the problem, or have the knowledge to do it. So I think, you know, in an advanced environment, You can just control packet size, the number of packets, the source of the packets, and the destination of the packets.
Where would that be done in? The,
In the appliance, in your IPS or some advanced firewall, because you know, and some routing system has security feature too, so you can also check, you know, so basically it's setting up the rules in the network appliances.
so the
and
rules
the-
can really affect,
oh yeah,
how does it, having the rules compared to, like, you buy somebody's security software?
well, when you buy security solutions, a good solution is one that would use your real world or your operational information. And sometimes, you know, and it's varied, right? It's just like buying insurance. Some insurance cover more than the other. So if you buy a good type of service, they are more thorough. Yeah, then they will control. There's some service that's bare minimal, and it might protect you and it might not protect you. So it's really down to the dollars on, you know, and then having the security appliances are not cheap. And then you can also have security appliances with live engineers that actually customize it as they go. So, or AI, right? So yeah, you see that. So Palo Alto has that kind of service that they would dedicate to live engineers to an enterprise network if you pay for that, right? And then, so with the appliances that you buy on top of that, they would have real people that not manages it, but enhance it, I should say.
But they're highly responsible if something does happen.
There is a shift in liability as far as something happens, but you know, it's all about agreements, right? So even if you pay a lot of money and you agreed and they provide you the service, but at the end of the day, if something happens and if your network is down 24 hours and you lose $5 million, will they pay that $5 million? Is going to come back to the legal aspect of the agreement. And then even insurance, right? So cybersecurity insurance costs a lot. Sometimes they pay a fraction of that, just like car insurance.
Yeah.
Yeah, typical. Okay. And then on the next one is the DNS reflection attack, where they send a lot of queries for your domain so they have to spoof the IP address again. So when you see distributed denial of service, just expect spoofing of IP addresses. So it's coming from many different sources with the same IP ID, right? Causing the DNS servers to respond to the victim in larger volume. So the servers is gonna want to respond back. And all distributed consume a lot of network bandwidth and so you would see that this attack consumes the victim network resources and resulting in website unavailability and the service unavailability because web is tied to DNS. Okay. So when they attack web, likely that they can do both, right? And they can do one or the other. It really depends on the attacker, their intention, the resource they have. There are many factors that can be involved. Question. The next one's my favorite. Okay. Because you can all be impacted. This actually is my favorite form of attack. Outside of, you know, there are some others, but I think DOS is really interesting but it's capitalized on something that's very simple, that's traditional, that's been there. But no, it changed. There's always new form of DOS attack, which is really interesting. So when I was in the field, a lot of it is just buffer overflow, like HTTP, stuff like that. Nowadays, I see a lot more stuff that are IoT related, like stuff like this. So, but these protocols been around for a long time. So it's just, people are thinking outside of the box and changing their approach, which is really interesting. Question. Mm-hmm.
So if I learn some stuff, right, and I go like sit out some company and like let the track it, right? And come walk in.
That you were paid or allowed to do, yes.
Yeah, that part, let them go in and so, hey, you know, you can do that?
No, ethically you cannot. You cannot scan and attack them and then ask them to pay you. That's almost like blackmailing. But there are Red Hat hacker that does that. The ones that hack cars and things like that. And they want to share the resources with the world, but ethically and legally that could be wrong. So some of these people, there are consequences behind that, right? Yeah, there are, you hear stories that, people get arrested and then the FBI, NSA, they would go and hire these people, but those are very rare. The key here is you don't want to be doing time to do good, right? No good deeds goes unpunished. You don't want to be like that. So making sure if you can scan with passive, but then when you start attacking, it becomes a problem, right? Even with scan, sometimes you have to ask for permission. So make sure that you have written permission and we're good. You can say that, hey, I'm new at this. You can go in there and you can talk to their IT team and say, you don't have security. I see that you don't have a security team. I'm trying to help you.
That's what I meant.
Yeah.
I didn't
Yeah.
go in
So
there.
establish that acknowledgement first is important. Disclosure and agreement. So next, simple service discovery protocol, your SSDP. This is using your plug and play devices like your printer at home. Things that you can just plug into USB and works. Smart devices that you plug the electronics in, turn on, configure your network, right? So, security camera system, very big, okay? It is a way to send a great amount of traffic and they can use that device to also attack internally. Okay. Because all of these devices advertises itself, right? When you turn on your printer, right? Especially my wireless printer, when I turn that on, if I need to look for it, as long as it's on the network, you see it, right? It acquired an IP address. It tells me the printer name. So a lot of these things are the give out its information to the other system. Now with this, that means that it's doing it's sending this information internally in that segment of my network. So it's using a multicast address. It's doing a multicast. Multicast simply is a broadcast to a specific group. And your router does it too. Okay. So with this, so you can see, right? Here is my plug and play devices. They just spoof those and send the request. Wireless printer of late is very dangerous.
Yeah, so, like, don't have like security like for that now,
No.
or it just needs to.
So think about your home network now. Where's the security? Your wireless router is the only security on that network, right? If you don't configure that, it's open sesame all game. So as long as I'm attached to your network, I spoof the camera system. Sometimes they can actually, if I can get here, I can see sometime your footage. I don't have internal inside home camera system for this reason. Mostly, yeah. Well, some model of camera are more secure than others. Someone had hacked my night owl camera long ago. Did I tell you guys?
No.
Yeah, I saw a bunch of scripts that they injected onto it when I logged onto it because I was like, why is it down one day? Because I overlooked it. I just didn't, I configured the open DNS for it because you can basically view footage on the web server, right? Those camera system, you can be anywhere and see what's at home. That's the point, right? Through the apps, you can do that, and that's basically the service. So one day, like I noticed that day it was down, and I logged on to it and looked, and on the interface I see that they added a script to it. Yeah, so pull it all right away. But I don't have indoor inside my home camera for that reason.
What about ring cameras? Are they safe?
I'm sorry?
The ring cameras indoor?
All camera systems are not all safe.
Okay,
Nothing is safe.
certain ones have, certain ones have what?
Certain ones have more flaw than others.
So it's application hardware vulnerability.
Sometimes.
than
Selling it like
network,
that.
or is it network?
If you're looking at this, like the plug and play component of it is basically just hardware based, or it's the way it's designed, right? Plug and play component is just, yeah, but some have more flaws. I've seen a lot of attacks through wireless printer.
Well, it's broadcasted, right? I remember, yeah. Just
So-
plug it with the USB.
Well, just turn your printer off when you're not using it.
Yeah.
Only turn it on when you print.
Yeah,
Yeah.
I use it USB.
And I've seen things that can be written to RAM printers in a network
Wow.
environment. So yeah, it's not it's things are endless, right? There's endless possibility on how things are attacked or hacked. Yeah, that's the fun part of it. Sure.
Can you imagine hacking like that in like a missile system?
They have that too, right? So when you work with a government agency or companies that contract in that area, there's a high need for security testing for nuclear based type of systems.
It's going in there like you're.
But ultimately it boils down to what? These systems are connected to other systems, right? You know, control center,
Yeah.
device. So, okay, for question A, it asks you what type of devices are exploited in simple service discovery protocol? How are these devices used in the attack? And those are your up NP, your plug and play, universal plug and play devices such as printers, camera systems, things that you just turn on and be able to, you know, if you can scan and see through your wireless, those, so because it would advertise itself. IoT devices, that's very popular. Like smart thermostat, your Alexa, Google Nest. Now they have smart light bulbs too, right? You can control it with an app and it was wirelessly connected. I showed up at home the other day and there were 3 installed, and I don't know, I'm on the fence about it, but
All that.
What's the worst that can happen? Like a fight party or something? Like,
well, no, it's connected to the device that control it. So the worst thing can happen is,
lead to another type.
yeah,
Oh,
well, yeah, and then they can get to the device that's connected to it. They can get to your network. Nothing's impossible, right? You always think of the worst case scenario, right? I tell my computer science student that. Always expect the worst case scenario for the app, right? And so in security, that's what we operate to, worst case scenario. Okay, so in the attack for question 9, how does the attacker spoof the IP address of the target system? What is used to send the spoof discovery packets to each of the device to request a large amount of data? So to break this down, UDP packets is used to spoof IP address. And that is used to send, well, first you need to spoof it of the target system. Then botnet or zombies that are grouped together would be used to send spoofed discovery packets to the device and request for data. So we know now, right, for after all of these forms of attack, if you don't use it, turn it off. If you don't use it, disable it. Isolated system is the best system. Not the best, but the most secured system. Any question regarding SSDP? So certifications, we need to know different forms of attack, different forms of DOS and distributed denial of service attack. And for 10, it asks you to give an example of the multi-vector denial of service, distributed denial of service attack. Why is the multi-vector DDoS difficult to detect? Because it is in multiple layers usually, and they normally couple the attacks. So it's combining one form of DDoS attack with another. So for example, is your DNS amplification attack, which uses network and transport. And that would couple with HTTP flood, which is at the application layer. So whenever you see HTTP, that's at the highest, which is layer 7. Because it can bypass some of the rules that are set for specific attack. So multi-vector just simply is different forms of attack combined. Any questions?
Can you read number 9 up a little bit,
Yeah.
please?
So a lot of the research that can be done, right, is that they would, if there are cases of attack like this, they would try to simulate the attack in the control environment and then be able to see, how it's done, how to prevent it, and so on. So some security company would do that, or even the larger enterprise network. And in the case that even if you're responding to the incident after the incident, you want to go back and look at the type of attack that happened to the organization and then sometime, retest it and see. So pen testing is really about testing. You basically perform stress testing. It's testing how far you can go before your system shuts off. So in the area of DOS for pen testing, it's really stress testing.
For number 10, would network segmentation help in any way? I don't see, is it a possibility that can help?
Network what?
Network segmentation.
Oh, to do segmentation?
Yeah.
It might help if they're spoofing from a certain IP address. But I think, internally, if they're already on that virtual LAN or LAN with a legitimate IP address, you can look at, so if they spoof the IP, like ARP spoof requires MAC and IP. So even if you filter MAC, it won't detect it, right? But if you, so you will probably have to block it based on the number of source that's coming in or the number of packets, like what we said before. Transport maybe do better job at looking at packet headers and things like that. Content related for the packets, like where it's going to, and if it's exceeding, like we said, 50 to that destination, just stop it. So you have to look at, how your rules are set with source and destination, and possibly the packet content from the header area. Because on the header, you do see that it reports like, you know, what's being sent. Yeah. I think a lot of the security appliance is capable of doing that. And then, yeah, so to be effective about preventing denial of service attack, you have, so as you being attacked, to respond to it effectively, number one, you have to respond quickly because it's a small window. Two, you have to quickly customize your security rules because if your rules are not effective and it's coming through, you have to quickly change your rules. So that's the key. So as soon as you get an alarm about, you know, and if it's coming through, then you have to shut it down quickly by just changing the rules. Question. Okay, so I think we're good with that part. Here are the steps. If you're interested, you can look through, right? I borrowed this from one of the cloud security company because their stuff is pretty good. It's up to date and it's adequate. So I pulled the steps down from one of the cloud company. So for SSDP, you need to block, and often it uses port 1900, by the way. Okay. So you can set that. Just block that port on your firewall, blacklist it. Multi-vector. So this middle boxes, this concept been around for a long time. A lot of textbooks don't have this. So again, I'm using some enterprise information and also tech information. So middle boxes are basically firewalls that are placed in the network, and it does deep packet inspection, right? These are more advanced firewall. They're labeled as middle boxes. And so, but in order to, so they said, well, you know what? If we're going to be blocked by these, we're just going to use these. So the attackers uses middle boxes to launch the attack. It's like I said, it's always so interesting. So how are they deployed? So I want to give you a little bit more information here. It uses asymmetric routing environment. So when you say asymmetric, that means that it's not identical. So they are different as far as connection wise for the packets if you have many. So to overcome this for the middle boxes, they would implement the TCP stack that's non-compliant. We know that TCP has a three-way handshake. It needs to acknowledge that it's going to establish connection, right? And then confirm it. So the way that they attack is to generate a sequence of requests that would encourage the firewall to respond, right? Because let's think about it. If your true protection is your firewalls, why not attack it? Why not use it to make it respond to you more and know other things so that way you can just disable it? So that's what they're doing here, is that it would just keep responding to the requests. So when they attack it, it's responding, and they attack it in a huge amount of volume of traffic. So it's amplified and it can be infinitely going. So it just crippled the firewall because it keeps responding, right? So these are some of the newer form of attack that you see through the middle boxes, and you see this happening with your security company and internet service provider. Okay. Then another form of the newer attack is called carpet bombing, and this is using UDP reflection and TCP reflection. So the destination is using a subnet or a CIDR. So you would see something like this, /22, /24, etc. And so it's harder to detect because the destinations are in not just in range, but in different subnets. So what they're saying is they're still performing a SYNAC form of attack. It's just the systems that we're normally blocking from, you know, a many system from the same IP address, that rule doesn't work anymore. So now they're using CIDR to kind of bypass for the subnet part. So strong in subnetting, right, would also allow you to think about how you can prevent it. So this is the data from Microsoft, 175,000 UDP, and this is in a small amount of window for the application attack. That's only on one cloud server that they're looking at. There were more than 10 attack vectors. And the most common, again, is your NTP. You already know what that is. And on that particular area or that region of system, 49,700 attacks. The DNS were 42,600 attacks. SSDP, 27,000 attacks. And there's Memcache, there's 18,200 attacks. No, this is throughout the 22 and 2023 year. I think they start to have some data for 2024. We're still pretty early in the quarter for that. So we do see this is the amount that's multiplied by, as you can see. So DDoS is still strong and ongoing. Okay. I don't think it's truly fixable. I think that we can reduce some of it. Sorry, I had some added. But you can add that as well for 10. So multi-vector uses multi-path. I mentioned this earlier, where a traffic is difficult to identify or distinguish from your regular traffic. And then your middle boxes are just the nation state censorship firewall. They do deep packet inspection. So who has nation state censorship firewall? North Korea, China, a lot of the communist country. So when you go to a state or a nation that filter web content, like they don't allow people to use certain websites or whatever, right? They use middle boxes. Or companies sometimes use middle boxes, right? And middle boxes are just firewalls that are used to send floods.
Somebody over from over here into the web bank over there. Use that, present North Korea and China stuff.
Oh, it doesn't have to be North Korea or China. Any type of middle boxes will do. So could be companies, firewall that's used for packet inspection. Those are packet firewall. So in carpet bombing, the attacker used different destinations within the specific subnet and CIDR, like the /22, we looked at that. An example would be a SYNAC reflection where the attackers send spoof SYN to a wide range of random or pre-selected reflectors. So there's a long list of things that we can do to reduce the risk of denial of service attack. One of the things we can do is to use a black hole routing to route malicious traffic away from the network into the black hole where it doesn't go anywhere. It ends. Yeah, so black hole routing is just a way that we route it away from our network. We can set request acceptance values and the time of acceptance limit for the server. So for example, like when it exceeds over 500 seconds, it times out. Or how many requests it would accept, like, 50 or 10, however many, okay, that you deem. And how can you tell? Well, how can you determine that? It's really, you have to take a look at the server request that's in existence, right? The usage of it. And you can find the information on the notes. I just condensed it slightly. We can place a web application firewall. So when we say WAF or WAF, is the web application firewall between the internet, which is normally represented as a cloud on your diagram for your network, and the original server. And we can create reverse proxy to protect the targeted server from malicious traffic. As I was telling Jose earlier, we can quickly create and customize web application firewall rules and filter requests as we see denial of service attack being performed through our tools or monitoring tools. You can use any CAS network to scatter the attack traffic across the network, like we talked about with using CDNs earlier, right? Very similar concept, where we would spread it out the network so that way the traffic could be absorbed and not be aimed toward one specific system or, that part of the network. Monitor, detect, and block anomaly IP addresses. Also layer 4 protocols and spoof IP addresses. So setting your firewall rules to block certain IP addresses, a range of IP addresses, or a certain type of protocols, which are in layer 4. UDP packets type of attack tends to be fragmented. So if you filter fragmented packets, that would reduce the risk of UDP reflection attack. And use TCP authentication mechanism to identify spoof packets for blocking.
Can you give an example for black hole routing?
I'm sorry?
Can you give an example for the black hole routing?
A black hole router, it's just you set route. So it would, let's say that it arrives at your facility, right? Goes through the firewall fine. And after the edge firewall, you have your router. On that edge router, you would set up, right, to check. Normally the router routes based on destination. So we would check. So you can also use your edge firewall to do that, to inspect the packets. So it's saying, okay, if we're using a single router at the edge, it would check the rule and it will pass on. And at the edge router, it would say, okay, the destination is this server. Let's route it to this area. But for the black hole, it would route it to a dead system, a null system. Just away from your network, right? So, but for the edge firewall, if you want, so if we're talking about like DMZ area for the web application firewall, you can also have it inspect the packets. And then for that packets, if we're using 2 router, because at the DMZ, likely you're gonna have 1 router for the private network, the second router is for the DMZ area. then you can have it sent to the second router for the DMZ area and then set route on that route.
Kind of like a proxy, the malicious, okay,
Yeah,
just another proxy tab.
yeah.
Yeah.
Well, you know, that what they say about security is a lot of it is we configure a box for another box.
Right. Yeah.
Cause in order to secure a box, we use another box. So that tends to be the case that, yeah, you set up a proxy to inspect the traffic for the other box.
It's like writing a website too, boxes inside boxes.
Perhaps.
Yeah.
So for the cloud provider, and this is generally the advice from the cloud service providers. So how do we mitigate distributed denial of service through a cloud provider? Let's say like AWS or Azure. And most company would use cloud services, right? So we can detect by IP reputation. Also based on common attack patterns. And based on historical or present data that we have for our infrastructure. We would block malicious traffic or absorb, just like what we do in the network, because cloud environment is just remote network, right? That's attached to our network. You can also route traffic in manageable chunks. So we need to do quality of service this way. We want to load balance and we want to size down the amount of traffic that certain system handle. So it's kind of like you normally let 1,000 people go through the border. We are going to size it down to 10 people at a time, right? That gives your system also resources to inspect and route. And then we also, with that, because we're looking at IP and IP range, we can analyze the pattern and the IP range from a certain location, like physical geolocation of the world, or certain logical location, which is systems, for security improvement. So 15, I wanted for you to kind of see where distributed denial of service is at right now. So I want you to visit the blog. You know, the tactic is to scare people into buying their product or service. But anyway, it's good to have information of where we're at currently through some technology company. So you would visit the URL that's provided there, just skim through the article real quick. It doesn't take very long and it chunks it up into various sections. I want you to be knowledgeable about where AI is in distributed denial of service attack, because that's where we're at right now. Once most of you hit the field, it will probably be used more abundantly for many different things in attacks. If my student can use AI to write code for their project, then AI can be used to spoof IP and other things.
Yeah, but you gotta talk to the way, you gotta finesse it.
Well, sometimes they have modified AI for that.
Just that.
You just, AI is really simple. If you can be specific with it, right? The more you teach it, the more it's gonna be more intuitive.
Somebody get into right faces. Whoa. Something bad.
Any questions? So for the last question, look at the article and then with the article, just answer the questions that I had stated for number 15. So go to the link. And I think in CIS27, you learn about polymorphic malware, how polymorphic malware works, right? So once everybody got most of the things down, I'll open the site. But if you read through the article, it'll tell you. And if we can encrypt traffic, they can encrypt traffic, right? So encryption for traffic is very common as well. And then question E asks you, what should be done to defend an application from distributed denial of service attack? Mostly the web application, it should be, but
They also use encrypted traffic to kind of, I guess, force TCP traffic as well, right? 'Cause I see that as
yeah.
part of, like the main thing.
Mhm. It's also bypassing a lot of the monitoring system, so it's just a quick, yeah.
All right. So UDP is more, I guess, what's the easiest attack vector, so there's more concepts to defend against it.
Yeah, because TCP just takes longer. And, you know, but a lot of the things we use also is in the horizon of TCP. So it really depends on the objective, the goal, or the system that they're attacking. Okay, any question? All right, so let me stop recording.